This is lesson 4-4, Linear Inequalities in Two Variables, Part 1. In this lesson, you will be able to learn how to graph solutions to linear inequalities in two variables. So let's review a little bit about the inequality symbols. The greater than symbol looks something like this, whereas the greater than or equal to symbol is the same symbol but with a bar below, to signify that it can be equal to in addition to be greater than. This is the less than symbol, so therefore the less than or equal to symbol would look like this. In 6th and 7th grade, when you would graph inequalities on a number line, recall that the greater than symbol and the less than symbol were open circles. If it was greater than or equal to, those were closed circles because those included the number. With the greater than or less than, it was up to that number but did not include the number. For graphing linear inequalities, how we will represent the open circle on a coordinate plane is by using a dashed line. And once we get into different scenarios, this will make a little bit more sense instead of you having just to remember. For the greater than or equal to or less than or equal to, those will be solid lines. So for now, go ahead and just sketch that in your notes. So new to this lesson is linear inequalities in two variables is similar to linear equations, except we use inequality symbols. So if we think of the slope-intercept form, y equals mx plus b, as an inequality, that would look like y is greater than mx plus b could be an example, or y is less than or equal to mx plus b. So instead of the equal symbol, we have an inequality symbol. Then we have solutions of a linear inequality in two variables. That's going to be all the ordered pairs that make the inequality true. So let's look at example 1 to understand what the inequality looks like in two variables. So I'm going to focus on A here. So we have y is less than or equal to x minus 1. So we have this symbol here, which is less than or equal to. In this case, anytime we see the less than or equal to or greater than or equal to, this is going to be represented by a solid line. If you look at this inequality careful, we notice that the y-intercept is -1 because that is our constant without a coefficient. And our slope is just 1. Anytime you have a variable x by itself, we know that there is a coefficient of 1 in front. So I'm going to graph this like if it were a slope-intercept form, starting on the y-intercept at -1. Because it has a slope of 1, I know that the rise is 1 and the run is 1. It is a positive slope, and I'm going to go ahead and sketch a solid line. Since y is less than or equal to, the less than region in this inequality is all this portion below the line. So any point on the line or in this shaded region would make the inequality true. So the solutions of the inequality are all the points on the solid boundary line and the shaded portion or the shaded region below. So this line, we call it the boundary line because for inequalities, there is a set of values that would make the inequality true. Okay, now let's look at B. If we look at B, we notice that the only difference is the inequality symbol here. So this greater than symbol is going to be a dashed line. We should notice that the y-intercept, or the b part, is equal to -1, and the slope is the same at 1. So we're going to go to the y, and the slope is the same. It is 1. Because it is greater than, this will be a dashed line instead of a solid line. And if we look at the symbol greater than, it means that it's going to be all of this region up here above the dashed line. So y is greater than x minus 1. It does not include the points on the dashed line because it's dashed, but any point that is on the shaded area would be a solution that would make the inequality true. So we are going to describe it as the solutions of the inequality do not include the points on the dashed boundary line, but do include the points in the shaded region above. Okay, now there's a couple that I want you to give it a try. Go ahead and pause the video and then check to see how you did. Okay, you should notice that in equation A, we have y is less than 3x plus 5. The y-intercept is 5, and the slope is -3. I can make that a fraction by putting it over 1. So here we have 5 on the y-axis, which is the y-intercept. Then I would go down 3 and over 1. Because it is a less than symbol, this is going to be a dashed line. And it is less than. So if we look at the y-intercept here, 5, we're thinking what values are less than that, and it's this entire region here. So that means this entire region would represent all the values that are less than -3x plus 5. So the solutions of the inequality do not include the points on the dashed boundary line, but do include the points in the shaded region below. If we look at B, we should notice that the inequality symbol is greater than or equal to. Same y-intercept of 5, same slope of -3. So if we graph this one, we will have a solid line because it's greater than or equal to. And since it is greater than or equal to, it's going to be represented by this region here, which is considered to be above the boundary line. So we would describe it as the solutions of the inequality are all the points on the solid boundary line and the shaded region above. Okay, in example 2, we're going to graph an inequality. So here we're going to look at a science club who has a goal of raising $750. To do so, they're going to be selling t-shirts and keychains to raise the money. The question is, how many t-shirts and keychains should they sell so that they meet or exceed the goal? So if I try to represent that with an inequality symbol, to meet or exceed is going to be greater than or equal to. Anytime you're given a word problem, we have to identify what the X and the Y variables will represent. Typically, whatever's mentioned first is the X variable, and what they mention second is the Y variable. So X is going to represent the number of t-shirts, and Y will represent the number of keychains. Now that we have these identified, we're going to write the inequality. So we know that the teachers $15 times X amount of t-shirts plus $5 times Y amount of keychains has to be greater than or equal to 750. So this is going to be the inequality that we use. So notice that that is a very similar setup to standard form. In lesson 3-3, we learned that we can find the X and the Y intercepts of a standard form by taking the X portion, which is 15X, and setting it equal to our total. To solve for X, we're going to divide both sides by 15. So that tells us X is equal to 50. If I go over here to the graph, the X-axis is the t-shirts, and I'm going to put a point at 50. Now we're going to look for the Y-intercept. I'm going to take the Y portion, set that equal to our total. To solve for Y, we're going to divide both sides by our coefficient of 5. 5 goes into 750 150 times. So we go to our Y-axis, and we put a point at 150, which is right between 140 and 160. Because this symbol is greater than or equal to, we know that it will be a solid line. And since it's greater than or equal to, we know that it could be any region above this solid line. So what do these values mean in terms of the fundraiser? So I'm going to choose a couple examples to explain that. So if they sell 50 t-shirts and 0 keychains, they will meet their goal of 750. Same if they sell 150 keychains and 0 t-shirts, they still meet the goal. Let's say they have sold 25 t-shirts and 140 keychains. They will have met or exceeded the goal because this is in the shaded area above the line. But if they sell 25 t-shirts and 40 keychains, since this point is below the line, we would know that they have not met the goal. So now go ahead and answer the try it. The science club wants to know, will they meet their goal if they sell 40 t-shirts and 95 keychains? Make sure to give your explanation in terms of the graph of the inequality. Will it be above the line or below the line? Is 40 t-shirts and 95 keychains in the shaded area or in the non-shaded area?